Welcome to SND College of Engineering, Yavla. In previous video, we discussed how to find the first harmonic, second harmonic and third harmonic whenever the values of yi is given in terms of the tabular form instead of the function which is to be given in explicit form. So here we see some example on the harmonic analysis. So see the first one. Find the harmonic expansion for y in terms of x up to first harmonic, that is we determine a1 cos x plus b1 sin x as given in the following table. So to find the first harmonic, we have to given the values of x and y. So the values of x, if you observe whatever the values we have to given, the values of x are to be equispace value. The difference between each values of x is to be 30 degree, and each value of x we have to given the corresponding value of y. So see the solution. We know that Fourier series expansion up to the first harmonic is y is equal to a0 by 2 plus a1 cos x plus b1 sin x, which is the Fourier series expansion up to the first harmonic only. So for that, whatever the terms we have required to determine the a0, a1 and b1, so we make the table for that values. So here see the first column is for the serial number, second column is for the values of x, third column is for the values of y, fourth column is for the yi multiplication of the yi and cos x, and the fifth column is for the multiplication of yi into sin x. So here we substitute the values of xi and yi which is to be given in the examples, and by using these values we find the values of column number 4th and 5th. So the yi into cos x and y into sin x, we have to given the value of y also and x also. So by using the scientific calci, we form this table and find at the end summation of each column. So here if we count the number of values of xi which is to be given, which is 12. So values of m we take 12. Now here the values of xi is to be defined in the interval 0 to 2 pi. So now the summation from the table we write here the summation of yi into cos x and yi into sin x. So first we write the formula to determine the value of a0. So a0 is equal to 2 into mean value of yi, that is 2 into 1 upon m summation yi, which is equal to 2 into, we substitute the value of m and summation of y. So 2 into 1 upon 12 into the summation of y, which is 95.6. So by calculating this we get the value of a0 15.933. Now similarly we write the formula for the value a1. a1 is equal to 2 into mean value of yi into cos x. So 2 into the mean value of yi into cos x, which is nothing but the formula for this mean value, which is 1 upon m summation I runs from 1 to infinity yi into cos x. So 2 into 1 by 12 into the summation is from the table minus 3.457. So the value of a1 we get minus 576. b1 now b1 is equal to 2 into mean value of yi into sin x, so which is equal to 2 into 1 upon m summation I runs from 1 to whatever the value we have to given, so 1 to 12, so yi into sin x, so which is equal to 2 into 1 by 12 into the summation from the table, which is 144.107. So by calculating this, we get b1 is equal to 24.01. So yi is equal to, by substituting these Fourier coefficient a0, a1, a2 in the Fourier series expansion up to the first harmonic, so we get y is equal to 15.933 divided by 2 plus minus 0.576 into cos x plus 24.01 sin x, which is a required Fourier series expansion up to the first harmonic. So in this way we calculate the Fourier series expansion up to the first harmonic. Thank you.